This is a Friday Shoes production. Our lesson today is on 6-3 in our books on page 316. Target is I can find the sum of the angle measures of a polygon and the measure of an interior angle of a regular polygon. Step 1, understand what a polygon is. I drew, you can see 4 of these here: triangle, quadrilateral, pentagon, hexagon, and those are just versions of those. But a polygon is any enclosed figure made up of segments connecting at their endpoints. No overlaps, no curves, no open space. Everything's closed in. So what we're going to talk about is the polygons and the relationship with their angles. More specifically about the total angular measure within these polygons. For instance, I think we all know that when we take a triangle, if we add up all of the angles in a triangle, no matter what type of triangle you will have 180 degrees. If you didn't know that, now you do. Any triangle, you add up all 3 angles and it has to equal 180 degrees. Now, how about a quadrilateral? Quadrilateral has 4 sides. In this case, I have a rectangle here. And what most of you would say is, okay, well, let's just add up the right angles here, which is 90, 90, 90, and 90. And that would equal 360 degrees. That's correct. Every quadrilateral. Quadrilateral means 4-sided, meaning any quadrilateral will have 360 degrees total. Total angle measure will be 360 degrees. Now, it's easy to look at that one and say, oh, I have 360 degrees. But if I gave you a quadrilateral that doesn't look like a rectangle, would you be able to calculate that? Well, here's a fast way to do this. Take and draw yourself a diagonal from one vertex to the other and create triangles. And notice how many triangles you see there, and you want the minimum number of triangles. There's 2 triangles that are needed to make a quadrilateral. So when you have 2 triangles, you have 2 180s. And when you take 2 times 180, you end up with 360 degrees. Cool deal. How about a pentagon? Pentagon has 5 angles and 5 sides. When you add up all these angles, how much is that going to equal? Not as easy as that quadrilateral there, because we don't know what those angles are. We don't have their measure. But we can break them into triangles, or take the pentagon and break it into triangles by drawing 2 vertices, or 2 diagonals from the vertex there. And if you notice, now we have 3 triangles. And if we have 3 triangles, we're going to take 3 times 180. And of course, that's going to equal 540 degrees. So the total angular measure of all 5 angles added up in the pentagon will equal 540 degrees. That's true for any pentagon in the whole wide world. All right, hexagon, 6-sided figure. I'm just going to draw our diagonals here. And I see that we have 1, 2, 3, 4 triangles. And that's going to be 4 180s. And I use my calculator, I get 720 degrees for that one. What about a 7-sided figure? You try to draw a 7-sided figure right now on your paper. It's pretty tough. I asked the computer to do it for me. Here's what I got. Now it drew me a nice regular one. A regular heptagon, or regular anything, hexagon, pentagon, quadrilateral, means all the sides and all the angles are, all the sides are equal and all the angles are equal in measure. So, but look at it, we got a heptagon here, and I draw the diagonals, and I can count, I see there's 5, inside there's 5 triangles. That's the minimum number of triangles. So I take 5 times the 180, it's 900 degrees. So a heptagon has 900 degrees total. All the angles added up, all 7 angles added up equals 900 degrees. Here's an octagon that has 8 sides, 6 triangles I can count there. And when I take 6 times 180, I got 1080 degrees. A nonagon, yep, that's it, nonagon, 9-sided figure. Computer drew it for me. I drew all the red lines. I see that there's 7 triangles inside there. Again, you're looking for the minimum number of triangles. I know some people will go, oh, I can draw a lot of triangles in there. No, you want the minimum number of triangles to make up that nonagon, and that's 7. 7 times 180, 1,260 degrees. All right, 10-sided figure called a decagon. Here's the drawing for it. And when I count all those little triangles, the big ones inside there, you'll see there's 8 triangles for a total angular measure of 1,440 degrees. That means if I added all 10 of those angles up, they'd equal 1,440 degrees. Now, I'm hoping you see some patterns here. Obviously, we've got the number of sides going up by 1. The number of triangles seems to go up by 1. And I know that the measurements over here, they seem to be going up by, if I recall, 180 degrees each time. So those are good patterns. But what if I gave you like a 32-sided figure or a 55-sided figure? What would we call those? They have special names. Think about it, though. It wouldn't make sense for us to give a name for every single one of the number of sides. So what we actually call those are n-gons. Whatever number of sides you have, put gon on it and you're done. For instance, 33-sided figure would be a 33-gon. A 55-sided figure would be a 55-gon. All right, now, question is this. What's the angular measure of those? How do you calculate those? Is there a pattern here that you can see? And I'm hoping you see some relationship between these here, the number of sides, and the number of triangles. Now that you're looking at it, do you see when we have 3 sides, we need 1 triangle. We have 4 sides, we need 2. 5, 3, 6, 4, 7, 5, 8, 6, 9, 7, and 10, 8. Do you notice that it goes down by 2? And then what do we do with that right there? Don't we take this? And what do we, oh, we multiplied it by 180. Yeah, that's right. That's all we really did. So take a look at what I'm going to show you here. I'm not going to draw you a picture of an n-gon. That's just, you have to know how many sides it is. But I do know this. The number of triangles you're going to be able to get inside of it is, well, take the number of sides, subtract 2, and that's going to equal the number of triangles. So it's just 2 less than the number of sides. And then to get to the total sum of the angles in that polygon, all you do is take that times 180. So notice what I have down here. Take the number of sides, subtract 2, multiply by 180. That's the total angular measure. That's how you do it. So this is our formula that we actually want you to remember. And there it is. Interior angle sum of a polygon theorem. It says the sum of the measures of the interior angles of a polygon is n minus 2 times 180, where n represents the number of sides. So what I would suggest you do is, S stands for the sum, but I would copy that down. So anytime you have a polygon, to find the total angular measure, all you do is subtract 2 from the number of sides, times it by 180. All right. Now this might be a repeat, but let's just go through this. If you're out there working on some project and all of a sudden you have a decagon and it says, and you need to know how many total degrees there is in a decagon, all of the angles added up, and you forgot your chart from up above, what would you do? You take your formula. You subtract 10 minus 2. You take the number of sides in a decagon, 10 minus 2. Of course, that's going to be 8. 8 times 180, 1,440. So the sum of the measures of the interior angles of a decagon is 1,440. Of course, we already had that in our chart up there, but I just show you that. Here's another 3 here. 2 of them you've done before. The last one we haven't done yet. You get to practice on it. Watch me do these first 2 quickly, and I'm going to have you do C on your own. Hexagon, how many sides? 6 sides. Okay. So take our formula, take the 6, plug it in. You got 4. 4 times 180, 720 degrees. Already did it above. You saw that. How about octagon? Take the formula, 8-sided. Octagon is 8-sided. You got to remember that, though. 8 minus 2 is 6. 6 times 180 is 1,080 degrees, meaning the total sum of all of the angles in an octagon equal 1,080. All right, how about a 15-gon? What do you do there? Same thing. Take your formula, take your 15, that's the number of sides, plug it in. 15 minus 2 is 180. or 15 minus 2 times 180 is going to be our final answer. So you got 13 times 180, which is 2,340 degrees. So in a 15-sided figure, all the angles will add up to 2,340 degrees. All right, let's take it a step further now. A polygon that is equilateral, that means all the sides are congruent. Lateral means side. Equal means, of course, the same. And equal angular, same with that. Equal, meaning the same. Angle, meaning angles. That means equal angular means all angles are congruent. So if you have sides that are congruent and angles that are congruent, you can look at the pictures there below. Those are called regular polygons. We can draw regular polygons. The easy ones are the smaller ones, the triangle, square, pentagon. You try to get the hexagon on paper looking regular, or even a heptagon. I showed you earlier in those pictures. I had the computer do it for me. It was a lot easier. Again, it says since all angles of a regular polygon are congruent, their measures are equal. So the measures are equal on regular polygons. Let's take a look at this question here. Talk about Frank Lloyd Wright. As a matter of fact, my dad used to live in a Frank Lloyd Wright home in Chicago. Frank Lloyd Wright was a builder. He designed 1,141 buildings during his 70-year career. He used obtuse angles and circles, creating unusual shaped structures, such as the Spiral Guggenheim Museum in New York City. Some of you may have been there. All right. Architecture, the question. The Enos Brown House in Los Angeles, California, shown at the right, was designed by architect Frank Lloyd Wright. The exterior of the house consists of repeating regular quadrilaterals. Find the measure of an interior angle of a regular quadrilateral. A regular quadrilateral. Do you guys know what a regular quadrilateral is? All the sides are the same and all the angles are the same, and it has 4 sides. Hey, isn't that just a square? That's correct. So, it says find the sum of the measures of the angles first. So if we take our formula, which is the sum is equal to n minus 2 times 180. A quadrilateral has 4 sides. 4 minus 2 is 2. 2 times 180, 360 degrees. The sum of the measures of the interior angles is 360 degrees. Now, divide 360 by the number of angles, the interior angles, and you'll find the measure of one interior angle, and that's what we're looking for. So the measure of one interior angle of a regular quadrilateral is 360 divided by 4, or 90 degrees. And we already kind of know that one. But that's how you would find the interior angle of a regular anything, any polygon. Take the total angular measure, divide by how many sides there are, or angles there are. All right, let's try that over here. It says find the measure of one interior angle in each regular polygon, round to the nearest tenth if necessary. Octagon. Well, we know that's 8-sided, right? Take our formula. First off, we need to find the total angular measure. So that's going to be 8 minus 2, which is 6 times 180. That's 1,080 degrees. So in an octagon, there's a total of 1,080 degrees. What about each individual angle? What are those equal? Well, if it's regular, like they say here, these are all regular polygons that they're talking about here. All of them are regular, which means the sides are the same length and the angles are the same measure. That means we got to split up the 1,080 degrees into 8 equal parts. So all we do is divide by 8. And when you divide by 8, you get 135 degrees. So what we would say is one interior angle is 135 degrees. How about a heptagon? Again, you can try these. Come on back and take a look and see if you can do it without me showing you here. Well, step 1, take the number of sides in a heptagon. That's 7. 7 minus 2 is 5. 5 times 180 is 900 degrees. Take 900 degrees, divide by how many angles there are, which is 7, and you get 128.6. That's rounded to the nearest tenth. So one interior angle is 128.6 degrees. All right, how about a 20gon? 20-sided figure that's regular. All right, well, first of all, we take the sum. Well, let's find it. Take 20 minus 2, that's 18. 18 times 180 is 3,240 degrees. Let me get my degree in there. Then we take 3,240 degrees, divide by the number of angles to get one of the angles. And one of the angles is 162 degrees. That is all we have. Don't forget, you can always rewatch the video for understanding, or look at the examples in the book, which I basically do for you here, or watch a personal tutor video on the online textbook. And as always, this has been a Friday Shoes production.